Hi friends, welcome to my channel. Let's have a look at problem 2578, split with minimum sum. In this video, we're going to share a treatment based on type conversion. So here the purpose is for practice. Notice that this problem is an easy problem. First, I'll read through the problem statement, and then we explain the idea or process. And finally, we do the coding. First, let's look at the problem statement. Given a positive integer called num, split it into two non-negative integers, nums1 and nums2, such that, first, the concatenation of num1 and num2 is a permutation of num. Secondly, num1 and num2 can contain leading zeros. So we are required to return the minimum possible sum of num1 and num2. Here are some notes. It's guaranteed that the num does not contain any leading zeros. In other words, num is a valid decimal number. Secondly, the order of the occurrence of the digits in nums1 and num2 may differ from the order of the occurrence of num. So here are two examples. So in example 1, so the output is 59. So here is an explanation. So you can have nums1 to be 2, 4, and num2 to be 3, 5. So we get this number. So similarly, we can have 25 plus 34, right? Still a valid one, and the sum of the output is 59. Secondly, nums2. In the second example, so num is 687. So we split 2. So we have a 1-digit and 2-digit numbers. So here, for the 2-digit one, we need to have 6 to be the most significant digit because this is smallest. So we can have 68 plus 7, that is 75, or we can have 67 plus 8. That's also giving a 75. So before we do the analysis, let's also look at the constraints. First, the num is bounded below by 10 and bounded above by 10 to the power 9. So with that said, we are ready to look at our treatment. So here, this problem, due to its easy nature, we are going to practice some type conversion. So here the idea is that we try to put small value digits in front, and also we need to try to make the two numbers lengths as close as possible. So in effect, so they are either equal in length or differ by 1. So in this problem, actually the assumption that num1 and num2 can contain leading zeros makes the problem easy. So here, let's look at example 1. So we have num is 4, 3, 2, 5. And if we sort the digits, and then we are going to have from small to large 2, 3, 4, 5. And then we try to make two numbers with 2 digits each, because here the total number of digits is 4. So otherwise we will have hundreds. That's not good, right? So here, the more significant digits position is, and the smaller digit we should put. For example, for N1, so we should first put 2, and then we put 3 in N2, and then we put 4 or 5. So let's put 4 in N1, and then 5 in N2. So you can actually switch the 5 and 4 or 2 and 3 because the addition operation in mathematics is commutative. So the splitting is not necessarily unique. For example, we can have 25 and 34, that's right? So we also get 59. So let's look at another example. So here we have 5 digits, right? And then from small to large, we have 0, 2, 3, 4, 5. And then we are going to have a 3-digit number and 2-digit number. So for this, so we are going to first put 0 in one of the number, and then we put the 2 in another one, then 3 in the first one, 4 in the second one, 5 in the third one, right? So we get 59 again. Again, we need to notice that the splits are not unique. So here is an extension. So what if num1 and num2 are not allowed to contain leading zeros? So this actually will make the problem slightly harder, but you are encouraged to try. So now, with that said, let's look at the coding part. So for the coding, in order to do the explanation, so I'm going to write with some redundancy. So this is just for illustration. So actually, we can write very short code. First, I'm going to write num to string. So I convert num into a string so that I can do split and then do sorting. So here we can use this string function, right? So num. And then next, I want to make this num to string to be a list. So this string to list. So this can be done using list keywords as a function. So we have num to string. So with that done, so let's do a sort. So now notice that this will be a list with element being the string consisting of digits, single digits. So now let's do this string to list sort. So I'm going to sort from small to larger. So here we can print out this string to list just to see what we have. Right. For example, for this example, we are going to have 0, 2, 3, 4, 5. So now let's do the split. So here for doing the split, so let's make some annotation. So here this is preparation, right? Next, so we're going to do split. So here we are going to use a very direct split. So let's see, in1 list. So I'm going to use string to list. So we are going to start at the index 0. Then we make a step. So we pick the first one, the third one, fifth one, and so on. And in2 list, now I'm going to do this similarly, but I'm going to start from index 1 and then pick every other one. So this gives the corresponding list for n1 and n2. So here, due to the assumption that n1 and n2 can contain leading zeros, this split will be fine. Next, let's get n1 and n2. So n1. So first, I'm going to use string John method. So we're going to have an n1 list. So this gives us a string. N2, we're going to have John n2 list. Let's give another string. Then we can use another type conversion. So we're going to transform this string or interpret this string as an integer, right? So with that said, then we just need to do the return, right? So we can return n1 plus n2. So this short piece of code forms a solution to this easy problem. So before we do any comments, let's first make a test. Yeah, it passes this cooked up example. Now let's look at the generic case. Yeah, it passes all the test cases. So I would say that's about it for this specific problem. So here we practiced the type conversions. Yeah, actually sometimes when we write the code, I myself tries to avoid using type conversion, but it's a powerful, sometimes can be powerful. So here, this is just one format of solution. You can for sure to modify and make the code shorter, even in one line. So with that said, that's it for this video. Thank you.